If you want to plug in your Apple TV, you spend maybe $10 on a standard copper HDMI cable, and you're pretty much done.
Yeah, that's really all you need for a living room.
Right. But if you want to route a live 8K satellite feed to a NASA control room, you need a single cable that costs over $1,000.
Which is just a massive jump in scale.
Exactly. Welcome to today's deep dive, everyone. We are exploring a product page from HDTVSupply, which is a 25-year global retailer of AV products.
And we're specifically looking at the DVIGear DVI-7366 8K HDMI Fiber Optic Extender.
Right, it's a mouthful. But our mission for you today is to look past the pure technical specs of this one cable. We want to uncover the massive invisible infrastructure that's powering the modern world's high-end video displays.
Because the sticker shock on this one item is, it's very real. Even with the retailer's 10% discount code at checkout, you're looking at an MSRP of $1,140.
Which is crazy for a cable.
Right, but you aren't buying a standard living room cord here.
So let me ask you this. If a standard $10 HDMI cable is basically like a garden hose, is this $1,000 fiber optic extender more like a high-pressure municipal water main?
That's actually a great way to put it, because standard copper HDMI is kind of like shouting a message down a crowded hallway. Eventually, the noise just drowns it out.
Because copper uses electrical pulses, right?
Exactly. And over long distances, those pulses face physical resistance, they bleed energy as heat, and they get scrambled by electromagnetic interference.
Oh, wow. So the signal literally degrades.
Yeah, but a $1,000 fiber optic extender is more like using a laser pointer in a pitch black room.
So distance and room noise don't matter at all?
Not at all. Because instead of electricity, fiber optics use photons bouncing down a microscopic glass tube.
And light doesn't suffer from electrical interference.
Right. That means an 8K pixel can leave a source and hit a screen miles away with zero data degradation.
But, a fiber optic cable is kind of useless on its own. It's really just a pipeline.
Yeah, you need something to actually drive it.
Right. If you have the capacity to move that much pristine data, you need a brain capable of sorting it. And that brings us to the ecosystem this cable plugs into.
The Wolfpack HDMI matrix switchers.
Exactly, which are listed all over the site.
Yeah, these are basically the traffic cops for massive AV over IP networks, which that just means sending audio and video data over standard internet protocols rather than dedicated direct cables.
Got it.
And the site shows configurations for these switchers scaling all the way up to monstrous 160 by 160 TV setups.
Wait, let me stop you there, because a 160 by 160 TV configuration sounds completely unnecessary.
It sounds like overkill.
Massive overkill.
Yeah.
Even the biggest sports bar in Vegas doesn't need to change 160 channels independently at the exact same millisecond.
Well, if it were just for changing channels at a sports bar, yeah, it would be overkill. But think about the logistics of what is actually happening under the hood here.
Okay.
Routing 160 distinct, flawless 8K video feeds simultaneously means you are processing terabytes of data per second and doing it without dropping a single frame. These switchers aren't just fancy AV plugs. They are essentially miniature supercomputers.
Which really explains the other side of this website, because if you dig around, buried in the site's navigation right past the sports bar packages, are dedicated purchasing portals for government agencies.
Yeah, the federal contracts.
Right. They list federal GSA schedules and NASA SUPI programs. And NASA SUP isn't for buying, office supplies.
No, definitely not.
That's NASA's dedicated procurement channel for highly sensitive IT, meaning this gear isn't just commercial grade, it's mission critical. So we aren't just looking at the nervous system of a casino here.
No, this is the exact same hardware running federal control rooms.
Which is wild to think about.
It is, and when you look at the video wall processors on the site, they range from simple 1x2 setups all the way up to massive 10x1 configurations. You really realize the stakes involved.
Right, because whether you are synchronizing 100 screens for a global broadcast or, monitoring live satellite feeds in a defense agency, the underlying need is identical.
Pristine reliability. A dropped signal in your living room is just an annoyance.
You just restart the router.
Exactly. But a dropped signal during a shuttle launch or a military operation, that is completely unacceptable.
So the next time you look up at a massive stadium video wall or a giant bank of monitors at an airport, remember the hidden, expensive infrastructure working behind the scenes.
Those 160-port Wolfpack switchers and $1,000 DVIGear fiber extenders.
Yeah, they are the incredibly complex pipelines keeping our entire visual world flowing.
It definitely shifts your perspective on what it takes to simply, put a picture on a screen.
It really does.
Mm.
Which leaves us with this final thought for you to chew on today.
Okay, let's hear it.
If it takes this much heavy-duty, government-grade fiber optic infrastructure just to route two-dimensional 8K video to flat screens today, what kind of invisible underlying technology will we need to build when our everyday environments transition to fully immersive holographic spaces?